Hi, my name is Travis Humes.
And Jenny Phillips.
Parth Shori.
Ijama Onyechukwa. Yolanda Watt.
I'm Jorge Matute.
I'm Alex.
And we're presenting
We'll be doing E2. So, E2 reaction is a one-step mechanism that involves two substituents. The name E2 derives from the fact that it's a bimolecular reaction. During the 1920s, Sir Christopher Ingle proposes a model to explain E2 reaction. The model he proposes involves a carbon-hydrogen and a carbon-halogen bond breaking to form a carbon-carbon
reaction. A proton is removed in order to form a double bond. And usually E2 reactions are, most of them deal with tertiary or secondary alkyl halides. However, there are some cases where E2 reactions deal with primary halides, and which this reaction occurs is second order kinetics because there is a starting group or the alkyl halide involved as well as a very strong base. It's two things. At the same time, we need a great leaving group on the alkyl halide so that it can leave once a hydrogen is deprotonated to form a double bond or pi bond. And so the starting material is usually sp3 hybridization, and the end product will be sp2 hybridization for a double bond.
Today we're going to be talking about stereochemistry involving an E2 reaction. A strong base is generally required, one that would allow for displacement of a polar leaving group. The stereochemistry of the hydrogen to be removed must be anti so that the leaving group, the pair of electrons from the breaking of the CH bond, denotes into the anti-bonding orbital of the C bond leading to its loss as a leaving group. So for example, we have OH as a strong base and it has two unstable electrons that's going to attack the hydrogen. The hydrogen is then going to form a double bond between these two carbons. The electron is going to flow along and eventually go to Br, causing the Br to become the leaving group. So for this reaction now, we're going to form a double bond from here, and then the molecules are going to spread out because there's less steric between them. So that will be the completed reaction.
For an E2 elimination reaction, you need a strong bulky base with a tertiary alkyl halide. An E2 reaction is an exothermic reaction and is a one-step single process. For a E2 reaction, the most favored is a tertiary alkyl halide. The second favorite is a secondary alkyl halide, and the least favorite and least likely to happen is a primary alkyl halide. An example of a base, a nucleophile that reacts with an E2 reaction is a third butyl oxide. Okay, so now I'm gonna show some examples that the teacher showed. So here I have an oxygen that this will react with this right here, and so I have basically I have this oxygen will react with his base right here. It will attack one of the hydrogens right here. I will attach to that, and hydrogen would double bond with this chloride, would double bond. So the final step, you have a hydrogen attached to the oxygen and double bond of the chlorine. And that's basically what I have to show you, and thanks for watching this video.